We've got Larry Harvey on here, and despite my original announcement, he's not from KFC because he asked me whether I wanted it crispy or original. He's from KSC, Kennedy Space Center. I've known Larry for quite a few years and then had the opportunity to visit him 2 or 3 times, and he's taken me on some great tours of Kennedy Space Center. So I asked him if he would, do a few slides and show us a little bit about Kennedy. And we had a chance this morning to go through it, and I'm sure you're going to enjoy this. The floor is open so that you can ask questions anytime you want. Raise your hand, and I will stop Larry. And you ask the question. I'll probably have to repeat it to him. But I think you're going to enjoy this, and certainly even as many times as I've been to the Cape, his presentation brings out a lot of points that I didn't know. So do any of you have any questions before we start? Okay, Larry, go ahead. You got the floor.
All right. Anyway, good afternoon, everyone. My name is Larry Harvey. I'm with the Center for Applied Space Technology. The Florida not-for-profit focused on space-enabled and space-enabling technologies, primarily in applications, how we can affect things for the common good with those. I'm a space brat. My father started in the space business in the early 50s. I grew up with it. My brother was a director for USA, went to the retirement of Shuttle people, and Twiggs being one of the more interesting ones, so I'm happy to be able to give you a little bit of a perspective of the history and the geographical setup of what we call the Canaveral spaceport. The Canaveral spaceport, as we call it today, is made up of 2 components. What you see on the screen right now is what's known as the Cape Canaveral Air Force Station. It's gone through a variety of names. Once upon a time, that was Naval Air Station Banana River. If any of you are Bermuda Triangle fans, you'll know that an ill-fated PBY flight took place out of there. But in the late 40s, early 50s, this became the nation's premier space flight and space test site. At the time, it had a lot of things going for it. As you can see, direct shot to the ocean. There's nothing downrange for a long, long ways, though there is some capabilities with that. There wasn't civilization within about 30 miles of the launch site here. And even now, they've managed to keep that standoff fairly well. The population at the time when this went down was probably in the whole area was probably less than 10,000 people. So this was a good spot, a good location, and for our nation's space program to begin. I'm going to focus. It's kind of interesting, but you'll see that early flights took place down in what would be the southern part of the Cape. This is known as the Cape. You can see this is the Cape right here. This section there. Flights took place in the early days in the southern part of that, and then worked their way on up through the north. This would be in the 50s and early 60s. This would have been the 60s, and then this is the 70s and beyond. And then there's another part of this that we'll get to, which is the Kennedy Space Center portion, which is separate from this side of the range. What I want to focus on the next couple of slides are where we the very first launch from here, which was Bumper, which was basically a V2, which took place from this area right here, Launch Complex 2, back in 1950. Launch Complex 17, which I'll show you a little bit of, which is still an active site, though we haven't launched from it in the last year or two, but it's the only active site, primarily active site down in this area. Launch Complex 5 and 6. This is where the first manned flight, U.S. manned flight, Alan Shepard, and then the second Mercury flight with Gus Grissom both took place from this area right here, this launch complex. Our first satellite launch was from right here, which was the Pioneer, which went on Jupiter. It should have been the second launch flight, or second orbital flight, but Vanguard failed, which I'll show you in just a little bit. And I have this spot in here because some of the pictures were taken from the vantage point of my office at the time, which is right there, what's known as the industrial area of Cape Canaveral Air Force Station. This is Bumper. Again, as you can tell, if you've seen any World War II video or pictures of V2s, this was basically a captured V2 that we played around with the upper stage. We had already launched a few of these in White Sands out of New Mexico, but this was the first launch from the Cape. Again, I believe it was in July of 1950. I know the year's right, I'm just not sure of the month. This was the first project that my father worked on. This is called the X-17. This was a hypervelocity vehicle. It was designed to go the speed of heat and then some, and the design was testing the nose cone design for what would become our ICBMs, our intercontinental ballistic missiles. It's kind of an interesting concept in it. It would get this tremendous boost up to altitude, and the upper stage would fire and drive it towards the Earth. So it had the effect of gravity plus the kinetic energy it had plus the booster itself. A lot of good things came out of that. My father was probably a bit in his early 20s when he was working with this. I could tell you stories of other signs of, or other forms of life that were launched on this, but I'll let you use your imagination since you're closer to age to what he was at the time. This was Vanguard. It's kind of interesting. This was supposed to put the first U.S. satellite in space. I'll show you why that didn't work. We thought we were going to get there first. We were very surprised in October of that year, 57, when Sputnik was launched. So this would have been the second one had this all gone. I kind of like this picture because one of the last conversations I had with my father, I asked him which one of the programs, and he worked all the way through the Shuttle program, which one was his favorite, and he said Vanguard, which caught me by surprise because all we ever think of Vanguard is failure. But he said, when I asked why, he said because you could put your arms around it, feel its heartbeat, and listen to it breathe. So I look at this picture, and I see this individual down here. I always, yeah, it could be. Maybe it's him trying to get his arms around it. What I think he was talking about, we never really got too much into that conversation, was basically the concept of systems engineering, something that gets lost in a lot of the things that we've done in the years since. But the fact that it's not enough just to know your job, but to know the relation of your job to everybody else's, and to be able to step in and when needed and when required. That's what happened to Vanguard. That was TV3. As a kid, my father had a scrapbook. It had a piece of this in it that I used to play with all the time. It was about 6 inches or 6 inches squared as a piece of the upper stage. It didn't work, obviously. That's the satellite that was recovered. I put that in there because it's about the size of a CubeSat. So it gives you an idea of what we were dealing with in the mid-50s. What is interesting is TV4, which was the next Vanguard satellite, did launch successfully and is still in orbit. In fact, it's the longest orbiting human piece of hardware, and probably will orbit for a long time to come. It's in an elliptical orbit, and I think its apogee is like 800 and something miles. Anyway, it stopped broadcasting after about 20 years. It had a very simple broadcast capability, but it did test a lot of new systems, including solar cells. A lot of the power came from solar cells, obviously, to be functioning that long. Going to the next one, when I showed you Launch Complex 5, again, I point this out. This is the Redstone Mercury. This is Alan Shepard, our very first American astronaut. This was his vehicle, his platform. Again, I wanted to show the scope of the rocket with the people that are standing here working on it. You see, it's not very, very large. In fact, it's kind of nice that we've come full circle with some of the things that we're launching now that are pretty much about the same size as this right here. So this was the Mercury Capsule at the top, and the Mercury Program, which was basically just to see if we could even survive in space. Alan Shepard was suborbital, followed shortly thereafter in 1961, followed shortly by Gus Grissom, who was also suborbital, both of them launching from this site. I believe it's about 200,000 pounds of thrust that was generated by the Redstone, but that's going deep in memory, trying to recall. Right after the successful launches, President Kennedy came to the Cape. This individual here is Mr. Davis, Kurt Davis, who was one of the German engineers that came following World War II, came to the U.S. He was the head of the Kennedy Space Center at that time. And it was shortly thereafter that the president made his speech where he laid the goals out, the objectives for the nation, which was to put footprints on the moon and to do it within the decade of the 60s. Going back to the look here, let's see if I can get rid of something real quick. Just trying to downbox it. There we go. Our next spot where we're going to go, again, just to reiterate, the Mercury launches were from here. The bumper launch, which was the very first launch, was from here, Launch Complex 2. And now we're going to go to the follow-on Mercury launches, which are from Launch Complex 14. You see how we've worked our way up the Cape. There were other things that were being launched. In fact, there was stuff going out of here all the time. For example, Launch Complex 21 and 22 was the Mace. And there's one that's somewhat humorous. The tour guides talk about it all the time. We had what was called the Snark, which was one of the first cruise missiles. It would launch. It had a JATO bottle, jet-assisted takeoff, which would fall away. And then it would be piloted by, it would actually be controlled by a pilot in an F-104 that was flying alongside. And it was designed, it had skids on it. That's why this is called the skid strip. It was designed to come back and land on the skid strip to be reusable. Because of the failure of many of them to do that, this area out here in the water in the ocean was known as snark-infested waters. I think that's even mentioned in Tom Wills-Wright stuff, so it's not original with me, but a lot of snarks ended up out here in the water instead of landing on the skid strip. This is the Atlas, the original Atlas, built by General Dynamics. After the first two launches, we decided to go to the Atlas. If you've read the right stuff or watched the movie even, or go up on YouTube and watch for rocket failures, you'll see an awful lot of these failing. It was almost a balloon. It had a very semi-rigid skin that would inflate as it and gain its strength as it was fueled. And a lot of times you'll see these things collapse on the launch pad. So it was with some trepidation that we decided that we had to get going. John Glenn was the hero who was chosen to fly in the Mercury capsule atop the Atlas from Launch Complex 14. And he made 3 orbits of the Earth. The launch, one thing I want to point out here, may come into play sometime in the next few years for you, is these were called vernier rockets. This is how the aircraft, or the rocket, got its stability when it was launched. And a lot of these verniers still exist and are being used for other applications. There are some rocket systems that have actually been designed around those vernier rockets. It's kind of interesting. One other complex that's there in the southern part is Launch Complex 17. They're twin platforms, twin towers. I've just shown one of them here, but what you can see in here, right inside that circle, is a Delta II. And this particular mission for the Delta II, which flew, I believe, I want to say 125 missions, but this particular one is Kepler. So if you followed Kepler, and which of course isn't working too well right now, but if you followed any of Kepler, this was the rocket, the launch that took Kepler to space. This is a Delta II. It's not the Kepler one. This is for a GPS satellite. But you can see Delta II. These are all droppable solid rockets. Depending on the payload, you could have anywhere from 2 to 6 of those, or 8, I believe. They would fall off at different phases during the boost. It was all to help in the boost phase. And of course, I don't have to say it, but the satellite's up here in this part right there. So, or maybe I do have to say it. At the completion of the Mercury program, we moved into what was called the Gemini Program. Mercury taught us that we can fly, we can operate in space. Wally Schirra did some pretty neat things with the Mercury Capsule, flying it around, actually physically piloting the airplane, or the aircraft, the spacecraft. But we had to get to the moon, there were a lot of things that we had to be able to develop, a lot of skills, and a lot of things that we didn't know about ourselves. We didn't know what would happen with prolonged exposure in spaceflight, for example. We didn't know how to do rendezvous. We didn't know how to do docking maneuvers, all these things which would be required for us to get to the moon. So the attention of the world, at least our world, turned to Launch Complex 19 right here for the Gemini program. There were some flights supporting Gemini that went from Launch Complex 14. There were some Atlas launches that went up to provide vehicles for them to rendezvous with. And there were some test vehicles that flew from Launch Complex 20. But all 10 of the manned Gemini flights went from Launch Complex 19. This is the Titan II Gemini. Interesting, and I was talking with Professor Twiggs about this earlier today, what we have done up to this point, and including the Titan II, was we had taken intercontinental ballistic missiles, things that had a function defense-related, and had tried to man-rate those, or human-rate those, so that we could fly astronauts on those. And there were lots of concerns, the things that you don't worry about necessarily with a warhead, that you do worry about with the human, with a brain and a limited compartment and everything else, where vibration loads were something to be concerned about. There was a lot of testing that was done. I believe 10 flights of the Titan II, primarily of the main stage, developing a dampening system to dampen out the vibrations. They had what they called the pogo effect, where it's kind of like what we call pilot-induced oscillations, but in this case, they would be thrust-induced. As the engines would light off, it would bounce back and forth literally, and it could go into a very dynamic situation very quickly. Came up with some very interesting fixes, which might be a good study, how they did that. I will tell you it had to do with the fuel lines, putting some systems in the fuel lines to reduce the vibratory loads that they were able to fly humans on this. Another interesting thing about it is the swing arm. This is what Gemini was famous for, the Titan II. That swing arm would fall away just literally just before the launch. And then all these umbilicals, as you see, which you're not used to necessarily seeing with the shuttle, since that's what most of you have grown up on, those would fall away upon launch also. There's Titan II Gemini in launch. Kind of interesting to notice here that it used a whole different propellant. It's a hypergolic. It's unsymmetric diethyl methyl hydrazine, and it burns relatively clean. So whenever you see that the clean trail coming out of the Titan or coming out of a rocket, you can be reasonably sure it's a Titan. We use hypergolics in a lot of things. It's very corrosive, and in fact, the whole area around this launch pad is a EPA site because of all the hypergolics that have gotten into the ground and into the groundwater in the area there. And again, there's another view where you can get a pretty good look at how clear that burns coming off of there. Even the shuttle had hypergolics in the reaction control system, so we don't get away from them, but it's just a little bit more difficult to deal with sometimes. This was a Gemini photo. I was asked to put this in by people who will remain nameless, but this is actually Buzz Aldrin, who was the second man on the moon, and I think it's the first selfie that was taken in space. Buzz was on he had done a rendezvous. He was Dr. Rendezvous, by the way. He's the one who did a lot of the math that was involved in doing rendezvous on orbit, which we would need to do to get to the moon and to get off the moon to get back to Earth. He was up testing one of those. They launched an Atlas with an upper stage that was a target vehicle. He was able to go and dock with that target vehicle. If you can see part of the target, this is part of it right here. That was how they found it. It was kind of like an antenna for them to home in on. And then he did about a 5.5-hour spacewalk. Until the Gemini program, we had never been in space. We had always been in the capsule in Mercury. Ed White was the first to get out of the capsule, and we did it several times after that. But a lot of the astronauts who would go on and walk on the moon and everything else, and some who went on beyond that into the shuttle program, for example, John Young, got their start in the Gemini program. I put this in because this is of great interest to me, and it's something, as a child, this was of great interest to me. This is what I expected to fly when I got to be of age. This is the X-20. Again, it's another good research project, particularly in light of some of the spacecraft that we're developing or even operating right now. This was called the Dynasaur, D-Y-N-A-S-O-A-R. Some really good graphics on it if you can find them. But it was going to be mounted on the top of a Titan and launch without shroud. It would launch just in that configuration right there. And it's basically a space plane. It would be flown around while on orbit, come back and land. The program was defunded, but a lot of the technology that went into that program can be seen in some of the work that we did with the shuttle itself and with programs now, the X-37, and even on the commercial side with Sierra Nevada's Dream Chaser. It just always looked cool. Getting back to the Cape, moving on up, at the end of the Gemini program, which again launched from Launch Complex 19, the next phase was to go into the Apollo program. And the initial launches for Apollo, for the Saturn, were done with the Saturn I and the Saturn 1B. And most of those took place in Launch Complex 34. And again, that's right here. That's a Saturn 1B at Launch Complex 34, just to give you an idea of what it looked like. They started launching these in 1963, so that gives you an idea how long we've been working on the Saturn program. This was one of von Braun's strokes of genius. In fact, the SpaceX Falcon 9 uses a lot of the same kinds of things. It's a cluster of engines right there, basically redstone engines that were used in the Mercury, but clustered together for the first stage. I believe on this particular one, I got a call. We didn't have cell phones in those days, so fortunately I was at home. But my father called me and told me I should be watching the sky. We grew up in Titusville, just about 30 miles, well, I was about 30 miles west of this site. They had, as a mass simulator in here, they had a bunch of water. I'm talking tons of water. And when it got to altitude up here somewhere, the water was, the upper stage was destroyed, and the water formed a very interesting cloud. You don't read much about it, but I remember it very well. It was our first attempt, I guess, at using space to make rain. Unfortunately, and one who hadn't flown yet, whose name just jumped right out of my mind, but you guys know who it is. Roger Chafee. We're doing tests about 6:30 in the evening. They had a spark inside the spacecraft, the Apollo spacecraft, and within a minute, all three of them were dead. We were using pure oxygen at the time. There was no easy escape for them to get out of there. There were lots of engineering lessons. Continuing this, which I think is pretty cool, that legacy continues. What you see over here, that's my car, what you see over there, but these are blast deflectors. Two different ones, two different angles of blast deflection. And in the distance here, we'll get to this, but this is Launch Complex 37, which is where the Delta IV is launched now. It was a Saturn 1B site and was reconfigured. This is where a lot of the ECS work was done, environmental control stuff that fed the rocket right up until launch time. This is where the site exists as it is now. The Air Force abandoned this in place And if any of you have been there, you'll know that someone marked up the L so it's abandoned in peace. It's a very solemn place for us space guys to go. After the fire, we had to do a return to flight. This is Apollo 7. I think it's kind of, I always like this picture because you can see the cars of the day parked right there. This structure here is where the launch team is, inside the launch shelter, launch shelter there. This distance from where it's launching to where these cars are is probably measured in yards, not in miles, like we measure in miles for shuttle launches today, but it was a little different world back then. And besides, it's a Volkswagen. I don't think anybody cared that much. This was, as I said, this was Apollo 7. This was our return to flight. One of the folks I got to be very good friends with while he was alive, Wally Schirra, piloted this spacecraft, Apollo 7, basically to ring out the Apollo spacecraft. Because if you know your history, Apollo 8, we went to the moon. We actually orbited the moon on the very next launch. And it didn't go on a Saturn 1. This is the Saturn 1B. This was the last manned Saturn 1 until after we had completed the Apollo program. So there were lots of interesting things that were learned. It's the first time we flew with a 3-man crew, for example, and the cockpit was not all that conducive to comfort, but they managed. And I think 2 of them had colds while they were there. So it was a real interesting time. Side note about Wally Schirra is he is the only astronaut who flew Mercury, Gemini, and Apollo. And in my conversations with him, he would have loved to have flown in the shuttle, but not, as he said, as a strap hanger. He wanted to pilot the aircraft, which I don't think NASA was going to let him do. Launch Complex 37, just talked about that. Again, we were just at 34. Now we'll move up to 37, which is an active launch site today. The active ones are all to the north end of the Cape Canaveral Air Force Station. This is a Delta IV, which is being constructed, manufactured, if you will. In fact, they're at the point where they're getting ready to put the payload on, and then the payload fairing. You can see that it also, if I can find it, down here you'll see, just like the Delta II that I showed you earlier, it has solids that surround it in this configuration. This is the standard Delta IV. The solids would also be there for a Delta IV medium. Again, the amount of solids and the reason for having the solids is to give that extra boost for heavier payloads. Or if they're going to something that has a different inclination. Right now at the Cape, you're at 28 degrees north, so anything from 28 north you can do fairly simply, launch-wise, power-wise. But if you wanted to go to any other inclination, it is a power concern. It does take power, which means that if you're not able to add power, you have to reduce payload. So if you haven't studied that, you will. This is these are my pictures. That's why they're the way they are. I'm sneaking in the woods to take them. Not really. I'm on the road. This is a Delta IV Heavy. When configured in the heavy mode, this is the largest space launch vehicle in the world right now. So, almost approximates the thrust, the capability of the Saturn V. What you see here are 3 core stages, side by side by side, and then the upper stage from that. Delta IV Heavies don't go very often. When they do, everybody wants to see them. It might be worth, anytime you have a visit down here, check the space launch schedule and see if there's a Delta IV Heavy. They're fairly spectacular. That's a fully constructed configuration. Again, you see these are all 3 core, liquid core booster or first stage with an upper stage. The structure rolls back before the launch and then off it goes. And there's one in flight. Pretty impressive. It's impressive to me. But again, if you see the whole sequence, these are some of the more impressive launches that you'll see, particularly at ignition, because there's this huge cloud of flame that literally goes, as it's still sitting on the pad, this whole part of the rocket is engulfed, looks like engulfed by flame, and then it rises up out of that. pretty spectacular. For a minute, you're not sure whether it's a failure or what, and then it rises through the flames. The next part that I want to show, again, these are active sites, but this was a complex. This was designed for the Titan III, and then later on for the Titan 34 and the Titan 4. But the Titan 3, Titan 3C primarily flew out of here. This was designed, the Titan 3 was used by DoD primarily, though it did launch a lot of our interplanetary probes also. It was used for spy satellite launches. It was kind of interesting. It was built on railroad cars, with that kind of a configuration, on tracks. The cars were on tracks. So they could be integrated right here, this vertical integration building, and then run up the track to either 41 or 40 for a launch. And they could do that within hours. And the idea was, again, if those that we didn't want to know were able to tell, if the launch was published a week ahead of time, then they could take proper measures to hide whatever it is that we were trying to go find or go see. So they literally would launch these just hours, hours notice going out. At the end of that program, and we'll get into this a little bit more as we go on, but all of this structure has been repurposed. That's a Titan 3C. The difference between this and what you saw with the Delta IV is that these are solids on the sides of the Titan 3C. The core stage, the center stage is a core Titan, the same thing that you saw with the Gemini, Titan Gemini, but these are solids. And again, it had a tremendous throw weight, a lot of lift capability with this thing. Now what's taking place on those launch sites is this is the new Atlas. You saw the old Atlas. This is what we're now launching. This is the Atlas V. And this picture was taken from what's called the VIP, the Vertical Integration Facility. And it's looking towards the actual launch site. And you can still see the tracks down here. In that sense, it still launches like the Titan 3, 34, and Titan 4 did. And these little engines push it right on out. It's fairly interesting. They'll do some ground checks, maybe a week or so before launch is scheduled. Then they'll go back to the VIP, and then literally the day of the launch, you'll see them push this thing out. So it doesn't spend a lot of time out in the elements. If you don't know, this is the Atlantic Ocean right out here. If you haven't seen it before, that's what it looks like. But this is the launch site, launch complex. That's what a launch looks like. I was, again, telling Professor Twiggs that we don't have any launch vehicles except for a Delta IV Heavy that inspire the awe that even a shuttle launch did, or in my case, what a Saturn Apollo did. But you see, we're still putting some pretty good thrust out of these things. This is being directed out of the blast deflector right here upon the initial firing of the Atlas main engine. You see that's pretty good throw weight. Hit it out towards the east for what it's worth. And there it is as it's lifting off. What's interesting about this rocket is that all the integration work is done horizontally. Very, very interesting to watch. When you go into, well, you won't ever have the opportunity now, but they ran 3 shifts with the shuttle when they were processing the orbiter for a shuttle launch. In any shift, any one of those 3 shifts, you would go in there and literally see hundreds of people that would be crawling all over it. Prior to that, with the Saturn Apollo, it was built, as you saw in the previous rockets, built in the vertical. So this is actually built and integrated in the horizontal. When everything's done short of the payload, it's taken to the vertical integration facility, and then it's raised pretty much like you would raise a pole, a flagpole, or anything like that. Raised up on its pedestal, rolled into the VIP, and that's where the payload is put on, where all the final processing takes place. And then it's rolled out for launch afterwards. The times I've been into the horizontal integration, I've seen 3, 4, maybe 5 people working on it. And the beauty, of course, is that they can get up out of their chair where they're working and walk to where it is that they need to test or do the other work that they're doing, where they're doing the integration, instead of climbing or going up and down stairs or elevators. This is one scene from my office. That's an Atlas V launch, looking out the window of the office where I showed you in the industrial area. I put that in so you can see I have a pretty cool job. This is an X-37. If you're not familiar with it, it was originally conceived by NASA and was turned over to the Department of Defense. It's got an interesting history. A lot of the original drop tests were done by flying it with White Knight, which, you know, is part of Virgin Galactic's program right now. It is, as we look at it, this is the whole thing. This whole thing flies. It doesn't, even though it looks like it comes apart right here, that's actually a payload bay. From wingtip to wingtip, it's about 14 feet. And I think this is about 30 feet. That looks about the right proportion. And it's about 9 feet deep. There's one flying right now. If you go up any of those tracking sites like heavensabove.com, you can see if you've got any passes coming overhead. Which, by the way, I highly recommend that. I was out kayaking this morning at 5:30 and had an International Space Station pass, which is, if you haven't seen them, they're definitely worth getting up and getting out to see. They don't all go at 5:30 in the morning. Sometimes you can see them at 8:30 at night. So, but definitely go out and check those out and satellites and everything else. So this is X-37. Right now it's running the black program. I think this one launched in February. It's still up there right now. The last one was up for about 5 months. It does land on a horizontal landing, and again, pointing out, if you've looked at the shuttle, you'll see that there's a lot of familiarity here. The difference is that when this launches, it's in a shroud, like you saw on top of the Atlas that we just saw in the previous picture. So it's not exposed to the G-forces, or, well, it is G-forces, but not to the aerodynamic pressures that it would have if it were just exposed, like the dinosaur I showed you was supposed to be. So it's an interesting thing. We really don't know what it's doing, whether it's testing hardware, whether it's just up there to make people angry. We don't really know, but that's the X-37. And again, the Atlas launches from this Launch Complex 41, which was an old Titan site, and then Launch Complex 40, which is another old Titan site. It's where you find SpaceX launching. And this is the Falcon 9. Again, took this picture from the road, from the highway that goes along there, the beach road. Again, this, if you're not familiar with the term fairing, this is the fairing on the Falcon. It can be when they're going to International Space Station as part of the commercial cargo contract. That can be a Dragon, which we'll take a look at in just a second also. Again, you see we've gone back to the simple design. It's not very tall, or not very long, however you want to look at it. It's processed in the horizontal. I was in there one day processing someone probably just a few years older than you guys, leaning back in a chair with a laptop in his lap, and a wire running into the spacecraft, and he was sitting there programming, configuring things. And he was the only person in there, so it gives you an idea what SpaceX is like. They go to work in shorts and T-shirts, very laid back, but very, very professional operation. I don't want to sound the other way. They've been very successful, but they don't seem to worry about a lot of the things that others worry about. Just another view of it coming up out of the mangrove. These, by the way, are catenary towers. You see a lot of these. These are for lightning protection. As it turns out, all the attributes of the Cape, one of the downside is that there's probably more thunderstorms in this area than almost any place else in the world. So to protect the payload and the spacecraft and not have inadvertent explosions, there's lots of lightning structure there. You may have seen this picture already, but if not, this is actually the Mayo Stem Cell Project team. Professor Twiggs. This is Dr. Abba Zubair from the Mayo Clinic, a stem cell expert. And this is me. And this is our SpaceX rep, Mr. Scott Henderson, who's retired Air Force. But this is the Falcon 9. The very moment that we're there looking at it, it was supposed to be launching, but it was delayed, so we got to go in and see it actually in the hangar while it was sitting there. This whole structure, it's assembled on this entire structure. It rolls out. This part is locked in on the launch pad It goes into the vertical. It's erected into the vertical, and then they put a couple of umbilicals across, do what they need to do, fuel it, and then they launch it. It can be done in a matter of hours. It's kind of neat because if you followed SpaceX at all, they've had a couple of false starts where they've actually lit off engines and then shut them down. Gone back, done some troubleshooting, a couple hours later launched the thing. You won't see that with a NASA project. It just doesn't happen that way. So that's where we're going. This is commercial. Again, there's the Dragon, if you're not familiar with the Dragon capsule. Right now, this is the cargo configuration. I know that we're looking at possibly flying our payload in the Dragon and maybe flying some CubeSats in the Dragon with a project, another project that we're working, Professor Twiggs, myself, and others, that hopefully we're launching one of these. The crew version will predominantly, again, if you can picture an Apollo or if you have that in view, probably take up that part there, and this would be your service, where all of the crew support, life support, oxygen, all your environmental control, and everything else are kept. Moving on, we've completed Cape Canaveral Air Force Station. This is Google Earth. Any of you can do this at any time and probably get a better picture of it than I do. But this is NASA KSC. This is the Kennedy Space Center, primarily. Some of the key points, particularly if you visited the Space Center, this is where the visitor center is, way down here at the bottom. Now you can go there and see Orbiter Atlantis. It's configured in its in-flight configuration, unlike the others, which are basically on sticks. It looks just like it did when it was in orbit. It's pretty impressive to see, and you can walk right around it. I highly recommend it. It's worth the trip if you haven't made it. If you're in Orlando for anything, zip on over to the Cape and take a look at that. This is what's known as the industrial area of the Kennedy Space Center. This building on the end is the Space Station Processing Facility. Every component that went up, every node, every nodule, everything that went up to the space station passed through this building right here. There's what's called, next building is called the Operations and Checkout. It was built to support the Gemini. I had the good fortune of actually seeing Apollo lunar lander in there when Tom Hanks was filming his series From Earth to Moon. They actually filmed some of it in there with a real lander, not the one in the Smithsonian's a mock-up. So,
Larry,
and then the headquarters building. Yes, Bob.
We need to kind of move on a little faster here. We got about 10 minutes left, but I thought I'd just, maybe
good point.
Should move a little
The
faster.
good stuff's coming up. Just other key points for you to see. This is where the vertical assembly building is. This is the shuttle landing facility. This is 39A and 39B, launch pads. And this is where the Atlas is launched. You can see how close they are, connection-wise. VAB, I wanted to point this out. This is Apollo 11, Saturn Apollo 11. You can see 363 feet, and you can see where that comes into the VAB doors. It would roll out 3.5 miles to the launch site. Just keep that in mind. These, by the way, are the firing rooms where the actual launching of the spacecraft takes place, including the shuttle. That's an Apollo 11 launch picture. You see the umbilical. One thing to point out is the platform that it launches off of. It was taken out there by the crawler and left on the launch site. Same process used for the shuttle. This is the Apollo spacecraft itself. This is in the Saturn V. You can actually go in and see that when you visit the Space Center. Interesting thing here, these are the lunar rovers, 3 of which are still on the moon. This is the lunar module. This bottom part is still on the moon. It served as a launch platform. This was the part that took the astronauts back to the command module. And all these things are still on the moon. So you've got communications gear, you've got power gear, and you've got transportation, and you've got a habitat capability. One of the reasons why they were left there was we thought we would be going back and we'd be able to utilize a lot of that gear. Something to think about, as you're developing strategies for the future. This is Apollo 11 returning. You can see that one engine, the key point of that engine is the only time that engine was ever fired was when it lifted the crew up off the moon. It was never fired in test, any of them. After the Apollo program, we did Skylab. I thought this would be interesting. This Skylab was the upper stage of the Saturn V. It was the first space station. We actually had astronauts on there for long durations, for weeks at a time. It was launched on a Saturn V. That's Skylab 1. This was Skylab 2, which was the crew that went up there. This is a Saturn 1B. Since they had to use the same thing, this was a double exposure. They're actually both on the pad, respective pads at the same time, A and B. But they built a milk stool to be able to use the same pad to launch the Saturn 1. That gives you, again, an idea of the perspective of the size of the Saturn. And that's Skylab in flight. There's stuff I could talk about that, but it's worth the study of what we had to do to utilize that. Again, just to refresh your memory, Apollo 11, the Apollo Saturn, using the full high bay coming out, assembled in the VAB and then rolled out. This is the shuttle on the last rollout that we had. Didn't use much of the high bay. In fact, as you'll see, the Saturn was about here, the shuttle's about here. To give you an idea of size, relative size of what's being used. And again, a good look at the firing rooms right here. The shuttle on the platform, the mobile platform, and underneath it is the crawler right down here. The same crawler that did the Saturn, moved the Saturn out to the pad, was reconfigured to do the same thing for the shuttle program. And it's being reconfigured now for the next one, which is the SLS, the next National Space Program. This was the last rollout. This is 135. I got to go out and see it. You can see the crawler down here a little bit better. It moves at slightly less than a mile per hour. It takes about 7 hours to go 3.5 miles. The whole structure on top of it. And there it is going past. It's actually only sealed or mated to this structure through the solids. The orbiter itself is just positioned in there. Another good view of it. I could go through the pad a little bit. Just know that the payload comes through this, the mobile service structure, which would swing over, cover the payload bay, push the cargo inside, wherever the payload was, and then close the doors. And it stayed in that configuration until launch. There are a lot of other things I could point out of this, but we'll do it at another time. Another view of that, and again, you can see that same wing profile that I showed with the X-37. This is what the shuttle looks like underneath. This is tile. This is basically DC-9 landing gear. A lot of the initial maintenance work that was designed for turning the shuttle around to fly to get the orbiter around was done using Delta Airlines DC-9s and Navy maintenance control folks who had worked with DC-9s. Just a point of interest, this would have been the Ares had we done it. That's the Ares 1X. You can see how far above the structure it stands. In comparison, I was able to get the shot with the shuttle on the pad and then Ares. We did launch that. This would have been the Moon, Mars, and beyond had we stuck with that plan. We changed administrations and changed our objectives. But we did launch this. There it is. It's basically 5 solid space shuttle solids configured into one rocket. Learned an awful lot about oscillations and everything else. This is one of Professor Twiggs' successful students who you may be dealing with somewhere down the road, came to visit and got to go out here and see a night launch. We were happy to host. And again, just if you haven't seen the shuttle launch, I don't know where you've been, but this is what they look like. That's Discovery right there, beautiful launch. Again, this is where the payload would be entered in. That was the next to the last one. We got to see it for just a couple of seconds, but you can see here that the sun, it was a morning launch, it was like 7 or 7:30. That's a shadow of the contrail up above the clouds being cast by the sun. It was pretty interesting because it went all the way across the sky. And then this is the fly-off. This is Discovery on its way to be basically stuck on a stick, and I think this one, yeah, it's in the Smithsonian, so you get a chance to see it and walk around it, but it's leaving the Space Center on the carry aircraft. In this final picture, I got up and positioned myself so you could see the shuttle flying away, the VAB, the vertical assembly building, which is the icon that's been there, from the Apollo days. And then this is the structure that the next launches will take place from. This is the structure that will support the SLS, which is the new spacecraft, launch vehicle that we're developing to launch the Orion to go to asteroids, the moon, Mars. We're not sure yet, but some of those places, maybe you guys will get to determine where. And that concludes what I've put together for you.
Okay.